Commercial parts can be used in space programs, but you need to be very careful about how you do that. You can't just take any part out of the equivalent of a DigiKey catalog and put them in your spacecraft design. If you do that, you're going to have problems. So right off the bat, what makes a good commercial part is having knowledge about the part's manufacturer, knowing that they're reputable manufacturers, knowing that you use space version parts from that same manufacturer and that from that same foundry, if it's an electronic part, can give you some reassurance that that supplier makes good parts. But the other key thing is data. You need to make data-driven decisions if you're going to go use commercial parts. If you don't have data on the parts, go get data. If you have to pay for data, you go pay for testing and you pay for data, because making an informed decision on whether a part is good or not good for a particular space application is critical. I think in just about every instance where we used commercial parts, we had some form of data on whether the part would be successful or not in that application. Commercial parts for space applications, if you're going to go out and buy them, it's good to know that somebody else has done it before. If nobody else has flown that part before with success, then you probably should plan a test program. And there's really two ways you can plan a test program. You can pay your supplier to do a test program for you, or you can do that test program yourself with the right resources. But really, you don't just grab something off the shelf and fly it. You ought to go test it. You got to go look through the body of literature that's out there. Maybe somebody else has already tested it, and you can get a hold of that data. On-ramping commercial parts on downstream Cygnus vehicles that'll fly on future missions. And absolutely, that is currently one of our strategies for making Cygnus both a reliable and a cost-effective vehicle for those missions. And so, yeah, we've created a methodology for identifying parts that are likely to be successful in a space environment and have the right performance and cost. And we are actively engaged in taking those parts and putting them in specialized breadboards and running them through radiation tests in order to show that they're capable. Now, the key thing with commercial EEE parts and space applications is for radiation testing, you're going to find parts that have what I'll call radiation characteristics that don't meet some strict letter criteria or bar. You're either above the bar or below the bar, or you either can be used or can't. What you'll find is these parts have characteristics, and you gather data to understand those characteristics, and then you go back to your system design at all levels, whether it's at the hardware level or the software level or the system fault protection level, and you craft strategies to accommodate those characteristics that you identified for those particular parts. Now, I say this, and you might say, well, that's going to cost a lot of money to go do that. Well, sure, but with the commercial parts versus, I'll say, traditional Class S or Grade B space parts, you're gaining the current cutting-edge performance capabilities of EEE parts that you do not get from the I'll call them the old-fashioned traditional parts that we've been using for decades on space programs. And so you can do things with the performances of these parts at a very modest cost. And then on top of that, we're learning that the actual activity of going and getting the radiation performance data for these parts is very reasonable. It's not that hard to do.